Week 8 of BUSA 207 Business Statistics. Last week we talked about discrete probability distributions. There were three main ones that we discussed. The first one was the binomial distribution, and the hypergeometric distribution, and finally the Poisson distribution. Just as a quick review, the binomial distribution had a characteristic of either two responses, either yes or no, or defect or not defect. So just two possible uh, outcomes, and the probability of a success is the same in each possible trial. So that's the characteristics of a binomial. The hypergeometric is similar to binomial, except it's without replacement. So now the probability changes each time you have a trial. And then the third one is the Poisson distribution. That was the number of events over an interval. And the interval, again, could have been a time interval or, for instance, a sheet of plywood, something like that. Well, again, remember that the data was counted in these distributions. Now we're moving into an area where the data is measured. And so now instead of discrete, we have continuous probability distributions. So the first one we'll talk about is the uniform distribution. It has the same probability of occurrence everywhere along the probability spectrum. From any point in the possible outcomes is going to have the same probability of success or of occurring. It's pretty simple. The calculations turn into a rectangle, so we use geometry, multiplying the length times the width to find the probabilities. It's sometimes called the probability distribution of little information. It doesn't tell us a lot. And so we sometimes use it to model a distribution we don't know anything about, and we just start with a uniform distribution to see if that'll work. The next continuous distribution that we have is the exponential, and the exponential distribution is the inverse of the Poisson. Remember, the Poisson is how many occur over an interval. The inverse is what's the time between occurrences. So if you have, for instance, an ATM machine and somebody walked up to the ATM machine, how long will it be before someone else walks up to the ATM machine? So that's called the exponential distribution. And again, it's the inverse of the Poisson. The third continuous distribution we have is the normal distribution. And the normal distribution is the bell curve, and we've talked about it briefly. This is the one that we really use a lot. The normal distribution is one of the most commonly used statistical concepts. Within the normal distribution, we have tools that we use like a z-score. A z-score tells us basically how far away from the mean we are in units of standard deviations. So we can take any normal distribution, not just the standard normal distribution, any normal distribution, and take a determination how far away from the mean are we. Are we close to the mean with a very small z-score, meaning we're not very many standard deviations from the mean? Or are we very, very far from the mean, way away, maybe 3, 4 standard deviations away from the mean, which is considered a long way away from the mean? And in a probability situation, it means that that occurrence is not very likely just based on probability. Where we will go with this is we'll come to a situation where we say, if there was no other effects except probability, this is the chances this event would occur. If that chances is 50%, well, yeah, it was probably just probability. But if probability says the chances of that event occurring are 0.00003, then you'd think, wow, that's not very likely. Maybe there's something else at work. And so with the probability, we say if what happened was not very likely based on probability, then there's some other factor that we need to look for. And that's where we're going with all of these distributions, actually, not just the normal. So as we get into the normal distribution, we'll also learn to estimate the binomial distribution using the normal distribution when we're dealing with population proportions. Population proportions can be frequently looked at as a binomial distribution, but we can estimate it as a normal distribution if the sample size is large enough. So we'll also talk about that. I hope you're enjoying the course, and that's what we have on our schedule for week 8.